Good morning. I think we're live. You have to tell me if anybody can hear me out there. Yeah, I think we were just mentioning, I think we've got a decent delay this morning. So I guess probably about 20 seconds. We're about to see here as the comments come in. See, people are ready to have their minds blown this morning.
There's an ad playing for all of us right now.
Oh, okay. So, all right. Oh, there it goes.
There's your mug.
Oh, there I am. Okay, yeah, good. All right. So I think everybody's. We're on. Oh, good. All right, excellent. I can hear. All right, so people can hear me. Fantastic. Good to see everyone this morning. Looks like I think there's an ad rolling right now. Yeah, Epic Times ad. Yeah, just all of a sudden you look on I have a little counter here, and all of a sudden like there's a certain number of people in the live view, and then everything just drops out and everybody goes away. So I guess it's rolling an ad. But all right, well, cool. Glad you guys can make it this morning. This morning I think we are looking at doing some automation today. So got a few things in store for you. Were there any, if there's any questions or anything from last week, please feel free to throw them in the comments. Brandy's over here. She'll be taking those. And let me know. Once again, we're running with about, probably about a 15-20 seconds delay. Brandy was saying it might be a little longer this morning. So we'll deal with it, do the best we can. And just know that if you go to chime in, I can see your comments as soon as you hear my voice immediately. The only thing is my voice is delayed, so just like every live stream ever. But cool. So I think this morning we'll start off with some review of last week, a few of the commands, take a look at it. We will kind of remember how to push a file to a text file, and because that's going to be key to what we're going to do today with automation. And then what we'll do is look at a command that somebody sent in over the last week that, not so much a command, but a tag you can put on the end of PowerShell commands that makes the output absolutely beautiful. So we'll take a look at that. And yeah, then we'll jump into some of the automation. I'm happy this week because a number of projects that I've got going on the side are kind of coming together. Some of you have been following me on LinkedIn and different social media stuff and have seen like this little guy, little RF detector. So I went from like this to something that looks pretty mean, looks like this, right? And that looks real sexy. And the only problem is this one was absolutely worthless. And then I finally got my new boards in, and I got this guy. So little adjustable RF detector, kind of cool. For those of you who are government customers, class, I think it's the applications TSM 201. If you come to the 201 class now, that project is replacing the final day project. It used to be the final day project was Wi-Fi and Bluetooth stuff, and I just had to move that to a separate day. Some of you guys have taken the course. There's just so much that happens on that day that it really needs to be 2 days, so that's been moved to a separate course. That separate course includes the Wi-Fi, Bluetooth, and it's going to start including some of the stuff you're going to see today. So you're actually helping me write material, which is great. So the stuff you'll see today will definitely there'll be some pieces of it in the new course. But the TSM, the 201 applications course is going to be getting the RF detector piece. So if you come back to take it again at some point, or you just want to come and take it, then that will be part of the course. So yeah, so I'm kind of happy. First time I've actually used the copper layer as a piece so that the logo can come out nice and shiny. So I'm kind of happy about that. It's the little things, right? Okay, so we'll take a look at some of the commands. Well, actually, before I even get into that, shrink my fat head here. Yeah, hopefully that's good enough. Yeah, if anything, if during the broadcast my head gets in the way, just let me know and I'll move it around a bit. If you're wondering kind of what's going on or what kind of stuff you needed to prepare ahead of time, if you go to the skinnyrd.com website, you will see a page will pop up that'll look like this. All the way on the left-hand side, there's an article that says Livestream Automating Host Defense with the Teensy and US Rubber Ducky. Click it and it'll take you into all the prereqs and all that kind of stuff. So I think a lot of people that were here last week came in for this week too, but some of you ordered the Teensy, and I saw that some of you had put on different pieces online that you had ordered it and it came in pretty quick, so that's cool. If you've got your Teensy in, we'll be using those today, so go ahead and break those out. If you don't, they're still available at the website. It's PJRC. They're like $20, and they do come in the mail pretty quick. Also, it's got a link here for the USB Rubber Ducky made by Hack5. And the main thing is there's a file here, defense automation file, so a zip file, and it has in it all the commands we covered last week, the JS Ducky encoder, a library that we'll be using for the Arduino later, and a Arduino INO program for testing the Teensy, and we'll go over that later. Then the MD5 and SHA, I put 245. That's a 256 SHA hash. There is not a 245 SHA hash. So, yeah. Excuse me. There's also some instructions and then some resources down at the bottom. Different things we're going to be covering today. So just make sure that if you haven't installed the stuff that's there, you haven't put the programs in, be sure to go there and do all that installation. Cool. All right, so got a lot of good mornings in the comments, so good morning to all of you guys. Zombie Land Rule 32, enjoy the little things. Okay, cool. Yeah. Thanks for the reminder.
You said it's the little things, right?
Huh? Yeah. Okay. All right, so we'll go over the commands. So last week what we did is we looked at a number of defense commands that we could use to look at a box, right? So we walk up on a box, we want to know, has anything malicious going on with that box? Has anybody done anything to it to screw with it so that they're able to remotely inject commands, those type of things. Like we mentioned the term cohabitation, right? So you're on the box, but it's somebody else on the box, right? And so this kind of helps you to look at those things and to see, like, okay, is somebody else here? Has somebody dropped something malicious? Is there a link that's going out right now? And we covered quite a few. Got the list up here right now. A lot of them were command line based. So if you bring up your command line for your computer, you can type, any one of these things in. So like system info does exactly what you'd think, right? It loads up and gives you system information for the box. We covered the WMIC commands. So they're different things, right? So WMIC QFE list. If we do that, that's going to give us, every hot fix that's been on the box, so every patch Microsoft has put on the box, so we can tell like how updated the box is, what kind of stuff is susceptible to if it's not updated. A WMIC disk drive, WMIC logical disk drive are two commands that we use to kind of look at the disks on the machine. Kind of everybody's two big ones that most people already know, IPig config all, which shows us all of our network interfaces that we have on a box, and also netstat, which shows us all the network connections. And what we said is you can put a dash A and O, and it gives us even more information, and it helps if I spell it right, but it gives us more information that's helpful. And some of that information is the PID, so the program identifier, so that we can match up. All right, so this is the particular program that opened that particular connection. So if I look down here, we've got a lot of connections out because I've got a lot of stuff opened. We have an established connection at 2432, or the program 2432. So if we want to find out what programs are open, we can go to task list /v. That means be very verbose in your output. And once again, I just got to learn how to spell. So that gives us a good bit of output. Try to get everything on there. And we can look up that PID from this list and figure out what exactly which program is actually running that network connection. And like we said also, which was brought up kindly by Mr. Pat, is that we can pipe that to more, and it will just slowly show us one thing at a time, so that if we can't scroll up to see everything, we can go down the list a little bit at a time. So different commands there to show network connectivity. We talked about net share, net user, query user. Query user is one of those things where it will show you users on the box. Oh yeah, Chris Andes just popped in there. It said task list /v. There's a find string, right? So if you wanted to find that particular PID, or let's just take 3884, so task list /v, we'll pipe that to find string, and I believe, let's see, 3740, and let it run, and there we go. So it'll just output that line. So yeah, it is like grep, like you just brought up there, in that if you're used to a Linux environment and you use grep will take, and it's a command you can go through and look at a bunch of output, and then it just prints the line for you that you're looking for. So yeah, good catch there. There's also, I was trying to remember, just for you guys who keep wondering what I'm talking about, pipe, we talked about that last week. It's this vertical line here. If you hit shift and your slash, it's up near the delete key there, it puts this little vertical symbol in there, and all that pipe means is that you're taking the output from one command, in this case task list /v, and you're pushing the output to another command, in this case find string 3740, right? So it just takes all that output and it pushes it over. And so piping commands one into another is a really nice way of being able to get to the exact output that you want. So cool. All right. Also, yeah, I was on query user last. So net share, like I said, that's just going to show you the shares that you have open on your box. Net user shows you user accounts for the box. Query user does not work for mine because I have Windows Home and I'm not on the domain. Some of you have Windows Professional Edition, or you might be on a domain. So if you run query user, you should get an output to see who's logged on to the box. We talked about PowerShell, right? So if you go down to, Windows key R, type in PowerShell, brings up a PowerShell window. I already have one opened up down here that I've been playing with. And you can run PowerShell commands. One of the things that we talked about was one called get PNP device. And that'll show you all of the past and present plug-and-play devices that have been on your box. However, we took and kind of picked some categories that we wanted to know about get PNP device. Looks like, okay, good. And the way that we did that is we added some things. We piped to a command called select, and we selected certain attributes that we wanted to know about the plug-and-play device. So I'm just going to copy and paste this because it's a lot to type, and paste this down here. Well, maybe. There we go. And so if we do it this way, it shows us all of these different devices, whether or not they're actually connected to the device, connected to the computer currently or not. There's some things, for instance, how this would be really helpful, right? If you, for your particular, say, enterprise or company, you don't allow, say, people to bring their Apple products or their phones or whatever in and plug them into the corporate system. You might be thinking, well, how can I figure that out? So for instance here, I've had an Apple iPad that's connected to my system. It tells me the manufacturer, the description, but it tells me false, which means that it's not connected right now, right? So, so Windows is keeping track of this kind of stuff. And one of the things that you can do is run this command to see, like, oh, who's been bringing stuff in, right? And if you're talking about a corporate, computer where you have some fairly stringent restrictions, I mean, if you're just open and just bring your own device, plug in whatever, okay, well, that's a different scenario. But if you have some kind of control on what people are plugging in and you want to know have they plugged it in or not, that's a good way to do it. Now, what I didn't cover last week, which after someone showed me this, I loved it, and then I went to some of my buddies that I work with on a day-to-day basis, and I was like, "Did you know you could do this?" And they were like, "How did you not know you could do this?" So apparently, I'm the only one kind of in the dark. But if you take this PowerShell command, and this really works with any PowerShell command where you can put things in kind of a table form, or you can, in this case, like delineate the output that you want. You can take and put another pipe at the end of this and type in out-grid view. So that's, let me move my fat head here. Yeah, so that's out-grid view. So if you put that in there, hit enter, what it's going to do is Windows is going to pop this nice screen for you where it displays all your output in a table form, and it's really, really nice. You can also sort on alphabetically for the caption. You can sort on any category, right? So I can sort on everything that is connected or everything that's unconnected, right? So this tells me now, just by sorting on present, everything that disconnected from the box, right? So obviously a lot of USB drives. I've got some interesting stuff, but like the fact that I've got a PC and there's Apple devices that have been plugged into it. Different ANT, right? So I got a GPS watch, so that tells you right away, oh, somebody's plugged a Garmin GPS watch because that's their special little protocol they use. So yeah, there's and a ton of hid devices that we'll find out why that's there later. But something new, right? So I've plugged in, and this is kind of interesting as well. So I've got a camera over here, a document camera that I'm going to be using today to show some stuff. And I have that document camera currently plugged in, and I've got, let's see, yeah. So sorry, I got the document camera currently plugged in, but there are 3 USB ports, right? So if I come down here to the bottom, IPVO, it should be there. Yeah, it says that it is plugged in. Up here, it says twice that it is not plugged in. Well, that's because there are 3 USB ports on the front of my machine. So I've got I've got 2 of those ports it's been plugged into, and it's not currently plugged into. One of those ports it is plugged into. And so that's how fine a detail you're getting with this. Now, question says, is it searchable? There is a filter piece up here at the top. So let me see. If I type in Apple, yeah, it will take and cut those results down to just show me stuff that says Apple, right? So yeah, in a way, it is searchable. Aux will, I believe, is what you got there. So cool. Yeah, so if you, I just thought it was a really cool way of viewing the output. Like I said, it doesn't work for everything, right? So if I go back to PowerShell, and you can run command line commands from PowerShell, like you can run netstat from it. But if I take netstat and then I pipe it to out grid view. It doesn't really do a great job of putting it in the individual tables. What it does is it sees it as one command with one output, not as individual outputs. Like with PNP, get PNP device, you have separate fields that output's going into. Like with this, you don't have separate fields, right? It's just there. Unless there's probably somebody smarter than me out there that can probably figure out how to delineate those particular pieces into the different tables. But just natively, just raw like this, it doesn't work that way. Cool. So that was kind of one of the extra pieces I wanted to cover. Out grid view. There's some other stuff. A lot of the stuff in PowerShell that we covered last week, we said it also is in command line. So we didn't really use it as much. But get process is the same thing as task list. Get net TCP connection is the same thing as netstat, but just for TCP. Get net UDP endpoint. That is netstat, but for UDP. Get net neighbor. All that is showing you your ARP table, right? So a lot of those commands are the same stuff we can get out of command line. There's not a ton of difference between the commands, those few commands there, and what you could run on the command line side using a similar command. However, on PowerShell, we did say there was one that was kind of unique, get local user, and that tells you not only the users that you have on your box, but whether or not the account is enabled or not, or active. So get local user is a nice one to have added to get PNP device. The other thing that we kind of talked about was moving these particular pieces so that you can output or I should say moving. So you can run commands and output them to a file, right? So it might not be advantageous for you to sit there and just look at the output for each thing. You might want to take and run the command and just send it to a file and then go look at it later. So one of the things you can do for command line or for PowerShell is we can take and tell it to send the output of a command somewhere. So if we do system info, one thing we can do is we can use these double carets here, I like to call, but pretty much that's just saying send the output of this, instead of going to standard out, I want you to send it to a particular file or a particular location. So in this case, we're going to take system info and we're going to send it to the desktop. So I'm typing out the full path there to my desktop. And as you notice, I didn't type every little thing out. Windows is great in that if you don't have the full directory name for where you want the thing to go, you type in the first few letters, you hit tab, it'll tab complete, and save you from having to type so much. So then I'm going to take and I'm going to name it the name of my computer, which is Sofa, which is the story I told last week. And if I run this, what it's going to do is run that command, and it's going to send the output not to the screen, which is considered to be standard out. It's going to send it to this file called Sofa, and there it is. So that's how you send the stuff. We did say though that so you can do this in PowerShell. You can do this in the command line. One of the things that I said you have to be careful about though is you really need to be careful about Wimic commands in PowerShell, because Wimic and PowerShell don't output their language or their output into ASCII. So if you run for instance, a Wimic command first, so let's go Wimic QFE list. We output that to, let's say, actually, let's just do this. We'll just change the command up here. Yeah, so I'm going to erase the file. Let's say I take the Wimic command, I push it to a file, Then I run my normal command, push it to the same file. It's just going to append it at the end because I use the double characters here, the double carets. If I were to use a single one, what it would do would be overwrite the file entirely with the contents of the command. But if I look at this, what it shows me is it shows me the output of WMIC QFE, and then the rest of the lines are completely garbled. And that's because WMIC doesn't output in ASCII, what it outputs in another encoding scheme. And sorry, a bird just hit our window. It scared the mess out of me. It outputs in a different encoding scheme. So what you kind of want to do is you want to make sure that you're outputting the commands in the same encoding scheme. So what we said last week was you want to take, for WMIC, when you run the command, let me just, oops, sorry, there it is. For WMIC, when you run the command, what you want to do is take and pipe that command to more. And if you just put pipe more at the end of it, it's going to output that command into ASCII. So if I run it and then I run our system info command again, take a look, now all the output looks completely normal, right? Cool. For PowerShell, we said it's a little bit different. Actually, it's a lot different, and you'll see kind of the form of it there. Is that you want to take whatever PowerShell command that you have, you want to pipe that to out file, then you want to give it the file path, append, and encode in ASCII. So there's a good bit more lifting for this. I'll just show you how it works. If we paste this in, so let's say my PowerShell command I want to run is get, let's do the get PNP device command, and let's just go full bore, right? So I'm just gonna copy that. Oh, and I should probably do this in PowerShell. So there's my PowerShell command. Next thing I want to do, I'm going to pipe this to out file. So that's saying, hey, write this to a file. So we do need to do this in order to write to a file, but out file. The next thing we want to do is our file path. Let me erase my old file here. So the file path. Let's go C, users, desktop, and then append, encoding ASCII. Oh, and I screwed up somewhere. Let's see where I screwed this up. Let's see. So out, oh, there is a dash between out file. There it is. Okay, and so when we go up to the file, we'll see all this stuff printed up. Okay, so that's probably about the nastiest command you'll see when we start doing this stuff is kind of that, because it's just kind of a really long command. But yeah, so now we know how to direct stuff to particular paths. The only other thing that we needed to cover, kind of review, is environment variables. So what we talked about last week is we can use environment variables so that it kind of makes our lives a little bit easier. We gave some examples, like if I put percent OS percent. Oh, no, it's not percent OS percent. Go back through my notes here. I'll just, yeah. Actually, that should have worked. Oh, yeah. No, it is. It did work. So echo percent OS percent. So that just means, echo just means print. So what it says is when you do that, it prints out Windows NT. If you can do random as well, percent, random, percent. And once again, echo that out. So it prints, and it just gives me a random number. But one of the things we said that's helpful is if we do user profile. So if we type in user profile, what it'll do is it will give us that home directory for our, it's going to give us the home directory and print that out. So if I want to take a file, an output for a command, say like system info, and I port that over and I want to take and send that to a file that's named by my computer, instead of writing C users JSON, I can just put %user profile %. And the reason I would do that is because if I'm running this on any box, right, I might not know the name of the box, or I might not know what the home directory is right away. So I can use this environment variable and it'll just auto type whatever the directory is supposed to be. I put slash, and then I want to go to the desktop. And then the last thing I want to do is put in the computer name. And so the way that we can do that is very similar. So we can go %, and I just want to make sure that I'm cool with this. %.txt. And it just appended it to the old output, but there it is, system info output. So if you missed that, all we did was type system info. We ported that to C/user/JSON, but just use user profile instead, /desktop. And then I said, whatever the computer's name is, name it that.txt. And so that's exactly what it did. And so we can use these environment variables to help us out when we're outputting information from these commands. We also said there's a way to do that in PowerShell. The way you want to do that in PowerShell is also with the not with the % signs, but you want to use a separate thing. And I'm going to bring this up here. So this is for get local user, and this just saved me some typing. And I should do this in the PowerShell window because it's PowerShell. So if we take the get local user command, we use outfile. Instead of using the %user profile for the home directory, we can use tilde, because it's the same kind of thing you would use in Linux, right? You use tilde to find the home directory. Say desktop, and then instead of saying %computer name, this is how you would write it in PowerShell. Use a $env::computername.txt, and then the normal command that you would use, the rest of the command you would use in order to format it to be ASCII. So if we run this, I come over here to sofa, scroll all the way down, I'm going to see the output here from that command. So hopefully the review was helpful a little bit. I know some of you might not have been here, some of you might have, but kind of just a quick review of all the stuff that we covered last week. And so now we'll get into some more of the automation piece of this. So I've got, let me bring up my, here we go. Yeah, that's good. Maybe I'll see what it looks like to turn the light on. Yeah, cool. All right, so I've got the devices we're going to be kind of looking at here today. Some of you might or might not be familiar with all of these. But what we've got starting from the left here is this is the USB rubber ducky. It's made by a company named Hack5. It is typically doesn't look like this when it comes in the package. It usually comes in a USB housing like this. So it's meant to look like a USB device. The maker of this thing originally made it so that he could automate administrative commands and make things a little bit quicker to do. So if somebody kept complaining about their printer driver needed to be loaded, then he would just automate it onto this and then tell people, hey, if you need your printer driver loaded, go to this closet, grab this USB stick and stick it in, and it'll load your printers for you, right? So, so what it is it is an auto typing device. So it is a HID device, a human interface device. And you might be thinking, well, what's the difference between that and just a USB? Well, so the computer sees this as a keyboard. it does not see it as a USB storage device. So a lot of places where you go, if you stick a USB storage device into a computer, alarms will go off all over the place. And so that is, or sometimes a USB stick won't even work, right? It'll just stop working. You'll get in trouble. There'll be, the computer can, there's all sorts of things that they can ways that they could respond to a USB storage device being stuck in a computer. So one of the things, and why this is pertinent to people who are doing defensive stuff, is like we talked about, a lot of these commands and stuff that are already on your computer, some of these commands could be compromised. So one of the things you might want to do, right, is bring your own commands, all these programs on a CD or on a USB thumb drive, and run these things so that you're pretty sure that the commands that you're running haven't been tampered with, because they're yours. But that can sometimes be problematic, because if you got it on a USB stick and you go to a place that has your stuff done pretty tight, and you stick that USB stick in, and now you can't run your commands because they don't allow storage devices, right? So the thought is, well, then maybe you can put it on a CD. So you might have to work something out with the admin on staff to figure out the best way you're going to get your clean commands onto that system. But the thing with the USB devices here is that when you stick these in, the system sees them as a keyboard. It does not see them as a storage device, at all. Now, the interesting thing about that is this one is, I'm going to say, it's fairly simple to use. You're going to see it can be coded simply, but there's no way to easily change the perception of what the computer sees it as. The computer will always see it as a keyboard, but it has a certain programming ID and vendor ID, or I say product ID and vendor ID in it that is associated with Hack5 as a particular type of device. So you can actually have, if somebody wanted to not allow even these, they could put a list on their system such that certain USB devices aren't allowed. So this could be filtered out, but it still, like on a normal system, will be seen as just a keyboard device. But really easy to use. All you're really doing is taking out this micro SD, putting your programming on it, put the programming back into the Ducky, and then slide it into your computer, and it just works. These two are called the Teensy. This is a Teensy 2.0. This is a Teensy 4.0. Both of these have little microcontrollers on them and a lot of GPIO pins. They are cheaper, they are faster, and they are more flexible than this guy. I can make these guys look like any USB device I want to on a computer. I can change the pin in the vid, and I'll show you how to do that today to anything that I want. I can change it such that it can be a mouse, it can be a keyboard, it can be a joystick, it can be emulate a touchscreen device. I mean, there's a lot of things you can do, and I have done with these that are beautiful. This guy is fairly old now. It still will do the job. If you just want it to auto type, it does the job for auto typing really, really well. And the great thing is it triggers on stuff, right? So, like, for instance, if you want particular outside sort of stimulus to trigger a certain typing behavior, these are all general purpose input-output pins, or not all of them, but a lot of them are. And you can trigger certain events. So you could say, hey, don't run the typing commands until I've pressed a button out here, right? The other thing is it comes with a small little LED so that you can signal to yourself when something happens, right? So you can say, hey, right before you start typing, I want this LED to light up for 2-3 seconds just to let me know that things are about to occur. So just a lot of flexibility. The penalty, though, is that you have to learn to program in C. So I'm going to show you a little bit how to do that today. There are tons of tutorials out there on how to program these things. Essentially, if you've heard heard of Arduinos, and control systems, so those little microcontrollers that you could buy, and every kid in 5th grade seems to know how to program now. If you can program an Arduino, you can program a Teensy. There's not much difference in the programming. So this is the 2.0. Like I said, it's fairly old. This is the 4.0. It's fairly new. It's just a couple months old, and it has a 600 megahertz processor on board. It's an absolute monster. In fact, it was moving so fast. My computer's about 6 years old. My BIOS couldn't handle it. It was mistyping on my computer because it was filling the keyboard buffer so fast and the USB buffer so fast that it couldn't cope. I had to reflash the BIOS on my computer so that this wouldn't overrun the thing. So it is an absolute monster of a microprocessor on this little bitty board. It will do all kinds of stuff. It will do, it has all kind of communications in and out. On the back of it, up here, it has a USB host support. So that means that normally you take this, you plug this in or this in to your computer, and you're able to program these things by pushing code to it. And that means that this is what they call a USB, kind of a USB client, right? So it's a USB device. On the back, though, you can solder onto these plates and turn this thing into a USB host, which means that you can feed it from an accessory. So if you wanted to push a keyboard to this thing and then have this thing relay the commands to the computer, you can do that because there's USB host support. So this can act as the master, so to say, to a client device if you wanted to. So it's if you take a look at the spec sheet that comes with it, it shows you all the inputs and outputs of this thing. I mean, if you're used to like cars and stuff, it even has a bit of CAN bus support. I mean, it's really just an incredible development tool. So I'd highly recommend getting one of these if you want to play around with some of the microcontroller stuff. Really quick, really efficient. So what we're going to do is we're going to start with the rubber ducky, just because the rubber ducky is kind of easy to use, and I'm going to show you how to automate with that and show you how what their thinking is behind that. And then we will move on to the Teensies. So if there are any questions about any of the commands or anything we've covered so far, just feel free to knock in the comments there. If you have any questions about the microcontrollers, just let me know. All right, so if you've got, if anybody out there has a rubber ducky and they're going to be following along, I'd like to know how many people in the comments have one on them or are going to be messing with it. If you got one, just throw in, yeah, I've got one, or I don't have one. What we'll do, though, let me get rid of some of this stuff, is I'm going to show you how you kind of build this. So put this over here, and at the same time we will go over some stuff here. So the USB rubber ducky, and I think I'll take first and extend this out. All right, cool. So we got, so David's got one. Sweet. So with the USB rubber ducky, like I said, you're going to have this little guy. Yeah, so we got some more people coming in with duckies. Sweet. And you've got this little micro SD card. Micro SD card that comes with it is like 128 megabytes. And it used to be, they said that there was a limit on how big a payload that you can have the Ducky type out. I have typed out massive payloads with it, so so you can actually put a fairly huge size thing. It's I've had it typed for so long that it's overrun the buffers of some keyboards because it started to outpace the actual computer. But yeah, so if you haven't gone on and taken it apart, take it apart. You get this board out, take your SD card. What you're going to want to do is take and plug the SD card into your computer. I use this little adapter that just allows me to plug the SD card into the adapter and plug it in. and this pops up. Normally what happens is you have an inject.bin file inside of it. And so what this inject.bin is this is the program that runs on the Ducky. If I were to open this up and just take a look at it and see what's inside of it, it just looks like this. It looks like trash. That's because that's all it is it's full of computer speak, so to say. And so it's not man readable. So what you have to do is you write your program in, say, Notepad, and then you're going to take that program and you're going to put it in what they call their Ducky encoder. Now in the file, in the zip file that I sent you, you had an HTML file in there called JS encoder. If you click on it, it comes up and looks like this. There are lots of different Ducky encoders out there. There's one that's online. There's another one you can download. I found this to be kind of the most reliable because it has taken every single very large typing project I've ever had for it, and it's always generated a good payload for me. So it's a really small, just JS encoder. It's beautiful. You can type your code straight into the script editor, or you can type it in a notepad. It doesn't matter, one or the other. Either one is good. Get this up. Cool. The other thing is I'm going to show you is the Ducky has a whole. Let me open this up in a separate one so I can refer to this back. The Ducky has a web page. It's a wiki that lets you know what kind of commands you can use. Some of the ones we're going to be using today is the delay command, the string command, and then this Windows GUI command. Be using those a good bit. There's some other commands here that are nice to know. Like for instance, if you're going to hit Control key, or you're going to hit up or down, or you need some extension commands. There's one on here that it seems obvious, but it's just not printed, which is Enter, right? So if you type Enter, that's the same as hitting the Enter key. It's a very, very basic script. And so if you're using what they call Ducky script to write a USB rubber Ducky program, it's going to be really simple to follow. Really simple to write, really simple to follow, really simple to execute. And just because of the simplicity of the language. So we'll go ahead and get started. So there's in fact, I'll just type it well, the reason I like to type it in a notepad is so I can save it, right? So I don't like to, I want to be able to, if the web browser crashes, I don't want it to lose what I've done so far. So the first command you want to know is one called rem, and that means remark. So I can say, this is my defense auto type script, right? All of the commands are in capital letters, and so that's why I put REM in capitals. The next thing that we want to do is start off with a delay. And this is going to be true for the Teensy and for the USB rubber Ducky, is that you want to put some delay right up front for two reasons. One is because you want to give Windows time to load the drivers before this thing just hauls off and starts typing madly. And so you don't want this thing to, for all of a sudden Windows to recognize that there's a keyboard hooked into it when you're halfway through a command. The other reason is because you will screw this up, okay? You're going to plug it in, and what's going to happen is you're going to have the wrong thing open, and it's going to start auto-typing in a window maybe that you don't want it to auto-type into, or you'll remember that, oh, you mistyped that, or wait a second, I don't think I need to be doing this right now. It gives you a grace period where you can rip this thing out of the computer before you catch the world on fire. I have, with the Teensy, had open an Arduino, like my own Arduino code that I was using to program the Teensy, plug the Teensy in, and then all of a sudden start to see that it starts typing across the code that I had written, ruining everything I had done, right? So that's when you hope Control-Z works for your undo. But given that delay, that 5 to 10 seconds, gives you kind of that period of time to think after you plug it in and go, oh crap, you unplug it, right? So we're going to add about 5 seconds here. If you're pretty sure the computer has seen a similar device before, the driver process will load a lot faster. Typically, on one that hasn't seen the device before, and if I'm going to be using this in unfamiliar computers, I'd delay it for 10 seconds. Just to make sure it has enough time. Good middle ground's 8 seconds if you got a decently fast computer. So I'll just leave it at delay 8,000. So the next thing what we want to do is figure out, all right, what key combinations can we press? And this is where kind of the discussion, I want to start with the rubber ducky, because these discussions we're about to have are things that we're going to have to do with the Teensy as well. And so it's good to have these discussions in the simplistic programming environment before we get into something a little more complex on the Arduino side. So we need to figure out, because we can't use the mouse, right? If we're plugging this thing in, everything has to be keyboard controlled. And so we need to figure out a way to pop the command line up. And so, you know, how do you do that, right? Because normally what we want to do is we might want to go down here and click in search and type CMD, or we might be used to coming to here and then trying to find a way to run. But we also said in our previously, one of the ways that we can pop up what we call the run window is we can hit the Windows key and R at the same time, and it will pop this little run window. So that's helpful, right? So we know that we want to hit Windows key and R so we can get to PowerShell or the command line or whatever we want. So Windows key R seems to be a good kind of solution for that. So we hit Windows key R, and then to pop a command window, we want it to type CMD, probably not uppercase, but CMD, hit OK, and pop the window so we can get started. So if we look at Ducky script, if we go back to here and we say, all right, so what can we use in order to, you know, pop a run window to do the, you know, the Windows key? It shows right here, it says emulate the Windows key, sometimes referred to as the super key. And it says we can either type GUI or we can type Windows, and that will emulate us hitting that, that Windows key. And then it says that it shows us an example. It says GUI R. It says this will hold the Windows key and press R, or Windows system resulting in a run menu. So they've already, this is such a thing that's happened so much, like, and people want so badly that they've just used that as the example. So that's exactly what we're going to do. So in our code, we're going to say GUI R, and lowercase r. And so what that's going to do is that's going to do that Windows key R functionality and pop our run box. Now you might be tempted at this point to go like, well great, so now let's type the command. So if we go back and look at our Ducky script and we say, well, how do we type things? Well, string. So string processes the text following, taking a special care to do auto shifts. So pretty much if we type in string notepad, what's going to happen is it's going to output you know, notepad is what it's going to do. It's going to type the word notepad. So what we want to do is we want to type CMD, right? So you go string CMD. After we do that, we hit Windows key R, and then we're like, okay, well, I hit Windows key R. I normally would type CMD, and then I would press enter, and it would pop it. Right? Well, that's great. So then we'd say, all right, well, let's just press enter. And that's the one that's not published on the Ducky script that I couldn't find earlier. But if you just type enter in all caps, it will the Ducky will hit the enter button. And you may think at this point you're like, well, cool, now we're right into the run window. So this is where programming with microcontrollers can really bite you in the butt. Microcontrollers, they run at a speed that is ridiculously fast. Even our little slow, like Teensy 2.0 here, is it will type faster than you for sure. And the problem is sometimes it will type so fast that it doesn't give our computers enough time to react. And that's especially true when you're talking about a GUI. If you're talking about command line, a lot of times The delays may or may not be needed because you can type and the command line can respond pretty quick. But when you're talking about actually producing a GUI to the screen, sometimes you want to wait a little bit, even if it's a few, 10 milliseconds, right? And so in order for the machine to actually catch up. One of the things I tell people when they're first starting out with microcontrollers and they're starting to have trouble is my first thing I always say is delay everything, right? Like always remember that you have to give the machine that you're working with time to catch up sometimes. And so you may have to insert delays. So we're going to do that just to be a little careful here. So after we hit Windows key R, what we're going to do is we're going to do a delay for just half a second. And really that's kind of a lot, but like you're doing defensive work, right? So like what's half a second, for you guys, right? Like you can wait half a second for this thing to fully load, no problem. And then after you hit string, and after it types in the command, we can hit enter right away. That's not a big problem. But before it starts just absolutely destroying the command line with commands, you might want to just throw a delay in there. I'm just going to put a 1/4 second delay, and I might even change that here a second, but just a 1/4 second delay so that the command window has time to kind of pop into place, and then we can get going. Some of your machines won't mind like without the delays; it'll just happen. Some of your machines might have problems with it, and so this is a concept we're going to use on the Teensy as well as on the USB rubber ducky. You got to insert these little delays, or before long it will mess with you. All right, so we've got it to this point. So we said Windows key R, okay, and now we're to this point. So now we can start typing commands. So like we saw above, we can use a string, right? String command, and we can start now with using our host defense commands, right? So if I come over here, so I'm just going to be copying and pasting from the host defense commands program here that I've already kind of put together. So first I want to take and say, all right, we'll type system info, okay? But if this thing's auto typing and it's auto typing command after command after command, it's going to do me no good whatsoever to sit here and try to read the output to the screen, right? So what we're going to want to do is we're going to want to push this to a file. So this is where our environment variables and all of that fun stuff come in very helpful. So we can take this USB rubber ducky now, we can plug it in any machine, and it should output the output of system info to the to a file on the desktop with that file being named the computer name. And regardless of the machine that we put in, as long as it's running Windows, this is where it's gonna output. So you'll notice I use a single caret here instead of a double. That's because this is a brand new machine. It's the first command being run. I want to make sure that every time I put the USB rubber ducky in to this machine, that it writes a new file to the desktop. I don't want it to append the first thing. I want system info to create me a brand new file. If you want to run a command if you want to run the USB rubber ducky on the same machine over and over again and have the output continue to be appended to the end of the file, just put you another caret in there and it'll do that. But this will ensure me that it'll overwrite the file right from the beginning. So we've got that. I'm over here shaking my leg super fast. My wife's like, you're shaking the house. So after we get it to type the command, next thing that we want to do is press enter, right? Because to execute the command. And then I know that this command takes a little while to run. So I'm going to give it time for it to run, right? So I'm going to delay it by like 4,000, right? So that's my first command that I ran. The next command that I want to run, I'm going to type string. I'm going to do wimic QFE list, caret that sucker over. And once again, so this is a wimic command, remember? So we wanted to output in ASCII, so we have to pipe it to more. I'm going to take my path, put it up here, and now Wimic's going to run. Enter. Delay 4,000. We don't have to delay that long for this one. If we delay 2,000 if we wanted to, it runs a bit quicker. But oh, and I need to put this on a different line. Right? And so now you kind of get the gist of it, right? So what we're going to do is we're just going to continue to kind of pop down one after another and continue to run the commands. And so kind of for your homework, what you want to do if you've got a rubber ducky is to make to go through and put the rest of your commands in. What I'm going to do though is I'm kind of going to expedite the process a little bit. But I guess before we do that, I should go down to PowerShell. So at some point, you're going to want to run the PowerShell commands. And what's really cool about this is from the command window, you would think, well, now I got to go and I've got to I got to take and go to the back to the GUI. I need to close this window out. I need to close the command window out. And then I need to do Windows key R, type PowerShell, and repop it. Great thing about the command window is I can just type PowerShell, and it will pop me into PowerShell. The reason I know I'm in PowerShell is because it gives me the PS in front of it. So now if I type in get PNP device, you'll notice that it's colored as if it would be in the PowerShell window, and I can just run it. So if I want to then get back out of PowerShell, I type exit, hit enter, and it pops me right back to command line. So I don't have to sit here and go through all the GUI mess of shutting down the GUI and then bringing up the PowerShell GUI. I can just take and type, go back here to my string PowerShell, and then enter. Give it a delay of a second. And now I can start typing my PowerShell commands, right? So I've already got one kind of done here, and you can grab this from your host defense commands if you want to as well. Pop this out. So this is our giant one. So the next one, of course, string, that monster, where what we're going to do is we're going to get PNP device. We want these particular attributes. We're going to send this to the out file. We're going to use this file path. We'll append encoding ASCII. Right. So that just kind of does all, our get PNP device, like the huge command. We're going to enter that. We're going to delay. I'm going to say 4,000 because it takes a while to run, and then we'll type our next PowerShell command, right? And so we can continue to put our next PowerShell. I think the next thing I'm going to do though is I'll show you how to kind of exit out of this, right? So right now you're in PowerShell, so not in the command line. So the next thing I would do is go string, and this is after I've typed the rest of my PowerShell commands, right? String exit, enter. And then I'm not even going to put a delay because it doesn't take long to type exit and get it to rock and roll. String exit again, because this is going to, the first one gets me out of PowerShell, the second one gets me out of the command window, and then enter, and then I'm done. So this will kind of generate, this is my Ducky script, right? So I can save this if I want to. It doesn't really matter if I do or not. I probably should save it if I were working on this, just so that I've got it somewhere, and in case Windows crashes or this crashes, like I've got it. But I'm just going to take now, and this is great. This is the text I want. And what I want to do is I want to move this to the Ducky encoder. So this is all the stuff we discussed so far has been kind of Teensy and Ducky centric. Like you can get some stuff from both, and you get some ideas for both. This is a very Ducky centric part of it. So this is how you're going to program the Ducky. Hit Control A. Oh, we got something popped up. If you don't want anyone to see what you're doing or keep others from asking questions, you may want to add the /min to run command as a minimized screen. Yes, you can do that. So So you can have this all kind of run in the background potentially by adding that. Actually, I am curious about, I want to look at something here. Let's try that. So if you type, so if it's GUI key R CMD /min, still popped it for some reason. I might have done that wrong. Let's see how that works. I have. So David, the one that I've seen that works if you want to get rid of the screen for this particular thing is not to hit the /min, and I might be doing this wrong, and you could feel free to throw in the comments and correct how I'm doing it. But one of the things I've seen to get it off the window is to run the command window, then have the Teensy or the Ducky, I believe it is, I have to remember, I think it was Alt? Oh, in the script, okay, yeah. There is a way, and I can't remember at the moment, but there is a way to pop this menu up at the top, and then drop down. And if you guys know what it is out there, put it in there. But there's a way to pop this menu from the keyboard. I thought it was the Windows key, but it's not. I thought it was Alt. It may still be. I wonder if it's Alt M. No, I can't remember. But there's a way to pop this menu in the upper left-hand corner. And what you then do is you hit arrow key down to move, hit enter, and then you just hit right or left arrow key and just move it right off the screen so that it kind of disappears out of view. Usually people go down because it disappears kind of below. So I've seen that done as well when you do this.
Windows key M.
Windows key M. Okay, so Windows key M. There it is. Oh, that definitely minimized everything. So yeah, so that minimized it quick. So cool. I make sure, and this is so this is, I'm doing this all off the cuff. The one thing that I've not seen is, and I haven't been able to, and maybe you guys can show me. When I hit Windows key M, it minimized everything on my screen here. So let me pop everything back up. The one thing that I haven't seen from when I minimize a window is to continue typing with the window minimized. So I might be wrong on that. Like, play around with it, see if it's something that you can affect. Normally, if I'm doing this and I want to make sure that not many people are watching, is I just have it, I take out a lot of the delay so I know what the fine line is and just have it type super fast. But the other way that I've seen has been to take and, like I said, drop that and then just move this off the screen with the arrow keys. In fact, I think in the Ducky script parameters, they've actually added that. So they added this recently. It's called repeat number of times. So what you can do is you can say down for the down arrow key and then say repeat 100 times, and it will press down 100 times really stinking super fast and just drop the whole window off the screen and run all these commands. And it's not minimized. It's the command, the window's still open, so you can type. I haven't figured out how to minimize it and continue to type on it. But you can 100%, I know, move the window out of the screen. So yeah, there are ways to mess around with that in different ways. And that's I'll after the live stream's up, I'll remember what that key combination is, and I can put it in the notes on the website for this. But to get back to the rubber ducky here, we've got this command here, or this program. I can hit Control A and then hit Control C. So I'm going to copy and I'm going to paste that in the encoder. So it will take and pretty much just drop your program in there. You click Generate Payload, and then it says, hey, you can download your output, and then just hit Download Payload, and it will download a file that is a .bin file. So I see a question over here. I'll get in just a second, but what's going to happen is it'll take this Ducky script, and then it will encode it so that the rubber Ducky hardware can read it, and it encodes it as an inject.bin file. So if I show that folder, it says inject.bin10. That's because I've got a lot of test runs on this thing. I'd rename it. Actually, first what I do is go to my my drive, my micro SD card. I'm going to delete the inject.bin that's there. I'm going to go back to this inject.bin. I'm going to copy it over to the F drive. Going to make sure it's named inject.bin. If it's not named inject.bin, you're going to have problems. The next thing to do is make sure, and I don't want my head, my head's not in the way, you eject it safely, right? So one of the ways you can do that is you can right click over here on the drive, hit eject, and it will remove it safely. So you can get this thing out. I'm then going to take and transfer it to the rubber Ducky, and we'll see if this screws up the world or not. So plug it in. So it's going to take, I think we said 8 seconds, so it's kind of blinking right now. It's getting ready to go, and we're going to see what happens here. Hopefully it'll pop in just a second. There we go. There's CMD. Starts writing, typing the commands, runs it. So that's my system info command. It's going to wait 4 seconds. There's my second command. It's going to wait 2 seconds for this one, I believe. I think it's going to drop straight into PowerShell. There it goes. Auto types. Okay, so it looks like I flubbed up my my command there. My fault. I have to go back and correct that. But the next thing it's going to do is wait a little while, and then it exits out of both of them, and it's done. So, so I did screw up. Looks like this particular command, I have to figure out what I typed wrong here. I probably screwed something up oh, yep, there it is, string. That's my problem. So thing is I can change that. It says my script's changed. I can generate a new payload. I'm not going to go through it again, but you'll take and then just reload it back on the rubber Ducky, give it another try. Once you've got it working on one computer, you're going to be golden after that. Here it is right here. So you can see it started a new file. It did my system info. It did my wimit command. It didn't do the get PNP device because that's the command that crashed, but beautiful. So we got some stuff up here. It says, let's see, if you don't have a rubber Ducky, can you save the file? Can you save the file as command file and run it from a remote location using something like psexec? Psexec. Yeah, be careful with psexec, man, because there's a lot of networks that I'd be surprised if you can run anything from psexec. I mean, you couldn't take this exact Ducky script and like save it that way. One thing you could do is you could write a PowerShell bash script that has all of these commands, and then take and have it sort through those. So you could have a command file, right, like written in like a bash script that would go through and run all of these, to where you just type one thing and then it pops through. That's something that you could look at, where it's just you run one, right? So yeah, there is the option of that. But as far as like run it from a remote location using psexec, there's a lot of there's a lot of people watching PowerShell and psexec right now, and that might I would imagine if you don't set off alarms, they have a big problem. See, it took me a minute to get in the chat. The script towards the bottom, it has command, script. Yeah, it does, and that's what we changed. String, actually. String twice, yeah, thanks for that. That's what I meant. So it would be good to initially prepare these based on the commands and name them in a prepared library. Then just rename them to bin, inject.bin once you put them in the Ducky. So would it be good to initially prepare these based on the commands and then name them in a prepared library? And then, so I mean, I generally like it's going to be good to prepare this ahead of time, like anyway. The thing is you still have to use the encoder. So I just can't take this file, right? And excuse me if I misunderstand the question, but I can't take this file and just rename it as inject.bin and then put it on the Ducky. It just won't work. It has to go through the encoder first. But so yeah, so I would say yes, it is good. You prepare the script based on the commands. Name them in a prepared library. So whatever commands that you want to run, whether it's commands that you've prepared yourself or it's like commands that you have on a CD or whatever, the Ducky will be able to, you'll just need to make it hit the right keyboard commands to run whatever commands you want. And then put it into the Ducky encoder to encode whatever this is that you decide to do, and then hit hit encode, and then download that payload in the inject.bin. Then move that inject.bin to the Ducky. The Ducky just does not work unless you have that inject.bin. So I don't know if that answered your question, B Will there, but hopefully maybe it did. Yeah, so prepare the file, encode it, then have them ready based on what you want to do. Yeah, that is, yep. Yeah, so like if you just want a set of commands that's going to give you system info information, then yeah, do that. If you want to prepare a set of commands that's just going to you say, an eject.bin script that's just going to give you network information. Yeah, so yeah, you could have a ton of different inject.bins just already made, and just they could be called network.bin, systeminfo.bin, whatever. Just make sure that when you after you encode it, put it in those .bins, that you take that file, you put it on the Ducky, and you rename it inject.bin. Yeah, but yeah, you're right. That would work just fine. Cool. So if you have any other questions about the Ducky, please feel free to put that on there. What's that? Yeah, and we're gonna go ahead and take a 5-minute break. Be back at say 5 minutes, so 11:23. Well, let's go at 11:25. We'll come back at 11:25, and we will finish up by talking about the Teensy and all the wonderful things it can do. Meanwhile, if you have any questions, feel free to throw it into the comments. So, yep, so break. Cool. If you can hear me, just go ahead and throw something in the chat there. We got a question. It says, does a double space between commands serve a purpose or just help you visually? Let's see, where is it? I'll just bring this up. This would be better. So I'm going to be putting this out on the website after after we are finished today, and this is just a script, a Ducky script of all of the commands that we talked about, and kind of the useful commands, right? Oh, thanks. Audio's good. Sweet. So this is just kind of a set of commands that are kind of useful, that I thought are useful, and it's been tested, so I know it works. And so I'll put this up on the website, on the webpage for this live stream. It'll just say something like post show notes or something like that, right? And so we'll have that. But the question about the double space between commands, I don't think they're double spaced. I think it's single space between this and this. I might not know what you're talking about as far as double space. I will say generally that I try to arrange code and script so that I can see what's going on. A lot of my code I probably overly comment sometimes, but yeah, if white spaces don't matter, generally I'll use them. I don't like to crunch things up, which sometimes can bite me in Python because white spaces do matter in Python. Luckily, I mostly do my stuff in C. But yeah, let's see. So it says line to line. Oh yeah, so line to line. Yeah, but you can leave spaces. It doesn't harm anything. Somebody made a comment that said you might want to look into the Bash Bunny. I have. So Bash Bunny is really nice because you can change what the computer thinks the thing is. And so if you want it to be a network device, you can say, hey, be a network device. If you want to, if you want it to be any particular type of USB device, you can kind of specify in the code, hey, be this way. And it's written in kind of the Ducky script kind of a way. Actually, you can use Ducky script on the Bash Bunny. And so it's a powerful device. Problem that I have using it on kind of a daily basis is I can do a lot of the stuff that I can do with the Bash Bunny on the Teensy and more stuff on the Teensy. So the Bash Bunny's pretty good. I will say this though, the Bash Bunny does let you emulate a network device and do some interesting stuff there. And I think you might be able to do that with the Teensy. I haven't really tried that. I just like the Teensy just because it gives me all these different input and output pins. So for my applications, a lot of the time, the Teensy's the way to go instead of the Bash Bunny. I've got plenty of Bash Bunnies. They just not. I just don't see myself going to them as often as I do the Teensy's. But yeah, if you're into the Duckies and you like the simplicity of the script and you want the ability to change from say a straight auto typer to a network device or to any other type of device, and you want a simple way to do that, then the Bash Bunny is a nice investment. Yeah. Let's see. So. Oh yeah, it's not possible to over comment code. Oh yeah, between delay and rim. So let's see. So so this white space, yeah, that's not anything critical. That's just for me to be able to visually see the break. Yeah, so it's nothing critical there with that white space. Yeah, it's not possible to over comment code. That's the truth, at least for me. Cool. So I'll have this payload on the website, and you can grab that. Cool. So I'm going to throw this over here. And I want to make sure. Yeah, cool. So what we're going to do now is take a look at the Teensy. I'll pop this up here. Yeah, so we got our Teensy devices here, the 2 and the 4. Like I said, the great thing about these is that they are faster, cheaper, and more flexible than the Ducky. The Ducky is really used for some good simplicity, but this thing is are really powerful devices. Even if you still have the 2.0, beautiful thing to work with. Pinouts, right? Like I wanted to show you this a little bit earlier. Everybody who bought a Teensy probably got one of these in their particular kits when it came. But like this is for the 4.0. We've got analog inputs, we've got digital inputs. If you want to communicate over UART, you can do that. If you want to communicate over I2C, over SPI, this thing, yeah, it even has a digital audio library on it. And the great thing about the 4.0 is there's stuff on the back. Some different pinouts, and like everywhere you see one of these little pads is pads you can solder into. Like I said before, I've soldered into the USB host pad. There's the D- and D+ pads right there for it. It's just a wonderful, beautiful machine that I can't believe only cost 20 bucks. So definitely, you know, if you're playing around with this, you can play around with it far more than what we're going to do today. But it's really, really nice piece of gear. You should have already loaded up the Arduino software. If you haven't done that, you go to the website. It tells you, I believe here, yeah. So go to the Arduino website here, download the Arduino IDE. I do not get it from the App Store, get it from the Windows installer, XP and up. Install that. I should have done that. Then the next part, it says to install the Teensy Arduino software. You do that from this link, and you're going to want the Windows installer. Just click that. Run through the install process. It's just going to ask you where the directory for your Arduino is, and it's going to install a bunch of libraries and boards for your Teensy Arduino. So that's for being able to program the Teensy, so you got to have that in place. So make sure you install that. The last kind of piece that you want to do for installation is you're going to come down to in the file that I sent you. There is zipped up another zip file called phukdlib. I will say foot lib. And what you want to do is you want to extract this. I'll show you how this is going to work. You're going to extract this to wherever, and inside of that will be a folder called capital. Oh, sorry about that. Called capital phukdlib with 2 capital letters in it on the P and the L. So you're going to copy that. So just right click, copy, and this is where the thing is that you got to kind of remember is now you have to find your Arduino directory. So so after you copy that, you're going to go to your drive that you have the Arduino files on. Most of you will go to C:\program files and then the Arduino folder. I'm just going to go to my Arduino folder. I keep it on a separate drive, so I'm just going to go to that. But most of you just go to C, program files, x86, and find the Arduino folder. So it'll look like that. You have Arduino. Open it. And you want the libraries folder. Double click on it. And you're going to see you will not have this folder in this directory. This is where you want to paste it. So you're going to hit Control V or paste, and you're going to paste the folder into the libraries folder. So that's going to give you access to these this library, these commands that can be run. So once again, that is unzip it. Once you've unzipped it, you're going to go into it, grab the folder that's capital P and a capital L in the name, copy it, find your Arduino folder into libraries, and paste the whole folder into libraries. So make sure you do that. I'm going to delete my old one here, gives people time to catch up. Cool. All right. So hopefully everybody's got that. After that, you want to run your Arduino program. So just double click on Arduino. I'm going to bring up a couple things and move them kind of off screen to kind of help me go through some things here. So just give me just a moment. Open recent, sweet, and bring me up a new one. So when you open it up, you should have a new blank Arduino sketch that pops up. It usually has the date up there. And let me see, which one do I want to do here? There we go. Cool. And yeah, you'll be ready to code at this point. There's also, just to be sure, I think everything should be loaded for you already. It's been so long since I've uploaded a blank Arduino from system. It should be, yeah, it's been a while, so my system's probably already set up for it. What I want you to do, though, to make sure that you have everything downloaded is if you click on Tools and you scroll down to Board, you should see in that list Teensy 2.0 and Teensy 4.0 in that list. If you don't see that, let me know in the comments. Or I should say, not if you don't see it. If you do see it, let me know in the comments. If you don't see it, you might have to do some reinstall. But if everybody are, yeah, just let me know if you got it or not, because that way we can figure that out. The other thing is, if you go to Sketch and go to Library, if you did the transfer right for the PHUKD library, you should be able to scroll down and find that library in the list. So that'll let you know that you did the transfer correctly. So hopefully that was set up right. So yeah, just let me know one way or the other as far as whether or not you're able to see that. And we will proceed. Okay, good, got it. All right, sweet. Got a lot of comments coming in, sweet. Excellent. So we will continue forward then. First thing I want to take a look at is under the Skinny R&D webpage, there's a resource called the Teensy Keyboard Emulation. This is the it's called www.irongeek.com. If you click on that link, it will take you to this page. Let me move my fat head a little bit further out of the way. If you go to this page, it will tell you all about how this guy uses this thing for nefarious purposes. There's some interesting stuff. He even uses the 2.0. This is an old website. I downloaded the library from this link. And there are a few commands in it that I like to use that are really helpful. And I'm going to show you a couple of the ones we're going to use today, and then I'll show you another one that might be helpful to you later. The first one is command at runbar mswin. So this is a command you can run, and it does the whole thing where you hit Windows key, R, and then type a command in and hit enter. All you got to do is type this in to your program, type in the thing you want it to launch, so CMD, right? Type it in there, and then you're ready to go. Like, you don't have to go through the hassle of trying to program, hit Windows key, hit R, it's just one command right there, and you're good. If you're running Linux or you're running OS X, same thing, you got a command for that. Further down, the next one that I like is one called press and release. So this will press a specific key when you put the key code in. You just put the key code in, and then so it's type press and release, put in the key you want, and then how many times you want it to press the key. Just a really nice function to have. Works really good. So we're going to be using those today during the class. The last ones that I want to just draw your attention to that you can do for homework if you want to try to figure out how it'd be useful. There is one here called Boolean is caps on. And so what you can do is you can ask the computer, hey, is the caps lock on? If the caps lock on, then you can take and use press and release to turn the caps lock off. Why is that helpful? Because you go to a computer, you go to run the commands, you throw the commands in, it starts to auto type, and then you realize that all the caps lock are on, and some of these commands might, you might have some commands that might be case sensitive, right? And so it would turn that off, especially if you type a command that reaches out, or let's say, especially if you type a command that has some sort of Linux component to it, and it is case sensitive, right? So this will help you to do that. You can examine numlock, you can examine scroll lock, you can examine all these and turn things off or on depending on how you want your typing to go after that, right? So we're not going to cover these today, but I just thought I would bring them up so that you've seen them, and you might be able to play with them later, right? The other thing that is helpful to look at before you kind of get going on this stuff is, and I don't know if I got it in the resources, but you can find it in Google. If you just type in Teensy keyboard, it is the first article that pops up. And what it does is it has a list of all the keys. So if you need to press a particular key with press and release and have it press it, 500 times, these are the keys you would use. You just say key B, right? And then have it actually press it that many times. Another thing is it gives the actual Teensy library stuff too. So for instance, if you type keyboard print and put it in quotes, that's the same as using the string command on the rubber ducky. Keyboard.print, put anything you want in there and it'll auto type it. If you want to go keyboard print and then drop down to a new line, you can do print ln and it'll hit it and drop it down to a new line. So there's a number of commands on this page that's just really nice to know. If you want to, they have something called the micromanager way, which is instead of using keyboard print, you very meticulously use the base level commands to send keys, because what you can do is you can send up to 6 keys at one time, and most people don't know that about the USB bus, but you can put a lot more on the bus than just 1 key at a time. So it shows you a way that you can get down and start doing this in a very base level of moving keys back and forth, and how that occurs and how your computer reacts to that. So that's another thing that I like about the Teensy, is that I get a lot of very fine control if I want to use the fine control for it. And it gives you a little warning down here which says, hey, USB keyboard limit is 500 keystrokes per second, and pretty much like this thing can maybe type faster than that. So you kind of have to be careful. You can type really, really fast with a Teensy, and your computer a lot of times will keep up with it. If you have an older computer though, with this Teensy 4.0, may the Lord be with you, because it might outpace your computer. A lot of times what will happen though is you have a keyboard buffer on your machine, and it won't start to outpace it until the buffer fills up. I found out with my machine on Friday that the buffer didn't matter, that the keyboard bus itself, the keyboard bus, or actually the USB bus, was having a problem with the BIOS in an earlier version of my BIOS firmware, so I had to completely update the BIOS to get the computer to keep pace with this thing. And so hopefully you won't have that problem, but if you do have that problem, you're going to have a bigger issue than I can solve over a chat window. So cool, we've got our sketch up, and I will go through and kind of show you the things you want to do. So the first thing you want to do is the very top, and congratulations, now you're programming in C, or the Arduino script. what I would do right away is just go ahead and save this thing off. So save it, and I am going to save this stuff under my class directory that I've got going on here. So yeah, so I'll save this as payload underscore test. All right. So now you'll notice after you do that, if you go back to that directory and look, it actually created a folder in the place where you wanted to save it. It created a folder there and put the payload.test.ino file in the folder for you. So it kind of creates, when you save it for the first time, it creates an entire project, not just one file. The first thing you want to do is you want to include that library that that we loaded previously. You can type that in a certain way, but if you are not a very technical person, the best way to do that, to know what libraries you have accessible to you, is to go to Sketch, go to Include Library, and drop down and find that library we installed and just click it, and it will auto type it for you. So that's the way you include a library in C, is you type the hashtag include and then bracket the name of the library, .h, another bracket. But like I said, if that's not your game, like you're kind of new to this whole thing, easiest way to do it, Sketch, include library, click it, it adds it to the top. So easy way to do it. The next thing we want to do is we're going to declare a few variables. And what a variable is let's say I have a number, like the number 10, right? And I want to make sure, and there's a lot of, say there's a lot of commands that use the number 10. Instead of continuing to write 10, I could have maybe a name for that. The other thing that means something, right? So for instance, in this case, we're going to make a variable for the LED pin on our Teensy 4.0 and the Teensy 2.0, and I'll show you how to do that. But instead of every time having to say, hey, pin, number 13, 13, 13, before long you're looking through your code and you're seeing 13, you're like, what was 13? What you can do is you can say, we're going to call this LED, and anytime I say LED, that means 13. Right, so it just makes it to where in my mind I know, oh, that LED variable, that's the variable for where the pin is, because I always forget where the pin is. So the way you do that is, if you're going to use a number, it's an integer. So you have to declare this variable first. You have to say, I want to make a variable called LED, and this variable is going to be an integer. So I say an int. I'm going to have that equal to whatever the LED pin is for your Teensy. If you're using the Teensy 2.0, that LED pin is 11. If you are using the 4.0, it's 13. So I'm going to test my 4.0 here. So LED equals 13. And at the end of that, I'm going to put a semicolon. When you're programming in C, every command you put in that is the end of a command, just about, you put a semicolon. And if you don't put a semicolon and you go to compile this thing or get it ready to work, it will let you know that you missed a semicolon, and it usually tells you the line you missed it on, but it can be a pain in the butt to find sometimes. So make sure you put your semicolons in. So we got that. And then we've got two things here. We've got a setup and we got a void setup and a void loop. So the way this works is void setup is a function that is run on your Teensy or Arduino. It runs it once and then it never runs it again. Okay? Unless you explicitly call it. But generally, it just runs once and you're done. So they put a little remark here, this / that says put your setup code here to run once. Anytime you put a / in, that's just a remark. So I'm just going to get rid of that because I don't need it. And at the same time, I'm going to put a remark up here so I can remember what this is. / pin 13 is for my LED, right? You'll see that they have some brackets here. So what it says void setup bracket and then an end bracket. What that does is that just says anything that you need to type for the setup needs to be between these two brackets. I like to take this first bracket and drop it down a line so that these two brackets are aligned. It just helps me to keep track of things. So our first thing that we're going to need to set up, so this is stuff that usually, like I said, it runs once. What I like to do the first time it runs, or when I plug it in, is I like for it to have a couple things. I want it to delay a certain amount of time, and we already talked about why we want it to delay. And then I want it to turn on the LED for a little bit to let me know it's about to run. So I'm going to tab over here. And the first thing I need to do is I need to set up to tell the Teensy that I'm going to use the LED as an output to turn it off and on. So this is just a command that's in all Arduinos. If you ever use an Arduino, you put pin mode, and then you put the LED pin number, but in this case we don't have to do that. We're just going to put LED because that is 13. And for you guys, using the 2.0, right, that's 11, but you should have put 11 up here in the here for your LED pin. So LED, and then I'm going to say this pin, this LED, is going to be an output pin. And then semicolon. So what I've said is I've got pin 13, you're going to be an output. Would make sense because, an LED is an output device. It'd be kind of silly to make it an input device. So this is declare output LED. And this is just a remark for me to remember. Next thing I'm going to do, I'll skip a line just to visually to help me. I'm going to delay. So if you just type delay all lowercase, this thing about Rubber Ducky, all your commands are kind of uppercase. In Arduino, most of your commands are lowercase. Go figure. So you type delay, and then I'm going to put 8,000. So this is in milliseconds. So so this is going to be time for computer to load drivers, right? So I'm just going to wait 8 seconds for that to occur. The next part is now I want to blink my LEDs. So these are two Arduino commands that this is an Arduino command that you might want to learn. It's digital right. And if you get it right, the great thing is it changes color for you. So digital right, and then bracket. I'm gonna write to the LED, and I want to turn it on, so I'm going to send it a high. Now I don't know what voltage that is. It can be 3, it can be 5, whatever. It doesn't matter. Arduino's taking care of it in the background. And so what I'm saying is, hey, turn the LED on, right? So that's what the command's going to do. Write to the LED pin and make it high. We already declared that pin to be an output, so this should be no problem for you. So I'm going to turn it on. Then I'm going to wait for 2 seconds. So delay 2,000. And then, probably guessed it already, before it gets going, I'm going to turn it off. So I'm going to write to it. I'm going to wait 2 seconds, and then I'm going to write to it again. But this time I'm going to say I'm going to send it a low, and the low is going to turn the LED off. So stay on for 2 seconds, then cut off and go. All right. So the loop is typically, I'm going to go ahead and correct this. The loop is typically where you put the main chunk of your code. Typically that's because what happens is it loops, it continues, right? So a lot of times these little teensies and stuff are made so that you will continue to run something, right? These are the brains for like robots, right? You just don't want to run one script for the robot and the robot stop. So everything you put in here usually continues to run over and over again. For the thing we were about to do, we're just going to have it run once and then exit. But generally, the void loop section is for you to run the main part of your code. Whether it loops or not, people by convention do it that way, right? So the very first thing we want to do, just like we did for the Rubber Ducky, is we want to pop the command line. And like I said before, we have this beautiful library that this guy wrote for us that gives us that command right here. Command at run when some command. I'm just going to copy it. And I'm going to tab over, paste that in there. All right, so The one thing about this is that there's some stuff we need to do. So one is we need to actually, in this spot, type the command we want, and it's got to be in quotes. So we're going to type CMD, and then put a semicolon at the end of it. So it's command at run bar mswin. If you get it right, it'll color itself. If you get it wrong, right, if you misspell this or something, it'll go black on you. But if you get it right, it'll turn red and give you the ability to see whether or not you typed it correctly. So what this is going to do is this is going to hit Windows key R, type CMD in it, and then hit enter. So it does all that for us in one command. So that's why I really like to have this library up here, is to be able to have that functionality. So hit enter, go down to the next line. How did you get to the library with all of the written commands? So I mean, to these commands, it's just at the Iron Geek website. It's on the, you go to Skinny R&D and you click the Teensy keyboard emulation link here. It takes you here to this list of commands. If you're talking about how did I push the library up at the top for the include, it was sketch, include library, and then go to it, click it, and it includes it up at the top. Hopefully that helps. But yeah, so that command's listed there. So after we've run CMD, just like we did for the Ducky, we want to delay, right? So I'm going to just delay 2 seconds, or in this case, we could delay 4 seconds, right? For this, or actually, this is just after we run. So this delay doesn't have to be, this delay doesn't have to be much. So I might just stop for a 1/4 second. Yeah, no problem there. Yeah, you're welcome. So just delay for a 1/4 second, and then after that, we're going to use the command over here in our Teensy Guino. Here it is. In our Teensy keyboard web page here, we have this command up at the top that said keyboard print. So we're going to use that keyboard print command. I'm just going to paste that in there. And so instead of having hello world be that, what I'm going to do is I'm going to type in one of our commands. So we will go with system info, just like we did last time. So system info, all right? And you'll see as I type this, that this wording kind of has a blue tint to it. I don't know if that's coming through in YouTube, but it does. So system info, and I might just put one of those, right, because I want to start off. Percent user profile, do my slash desktop slash percent computer name, .txt, and so we put the command in there, and you'll notice that it went from being this kind of bluish tint to a blackish tint. And the reason is because something didn't translate well. And the thing that didn't translate well is this is something in C that you have to watch out for. Anytime you put anything in quotation marks, if within those quotation marks you either put a slash like this or another set of quotation marks inside of it, you have to use something called an escape character. And the reason is, so let's say you want to, your file name or whatever has a quotation mark in it, right? Well, what C does is it says, wait, that's a quotation mark right here. So that quotation mark goes with this quotation mark right here. And so it doesn't know that this is something you want typed. So what you have to do is you have to designate certain things with what they call an escape character. And I've got a link at the bottom of the website. It says geeksforgeeks.org. If you open that up, it shows you a list of escape characters that are in C when you have something in quotes that you can use for different things. The 3 that I want you to focus on is the backslash, the single quote, and the double quote. And so if I want to put a backslash in my command, I have to put a backslash in front of it to designate that the next backslash is actually part of the command, not something that needs to be used for C, because the backslash is usually used to designate a particular thing you want to happen. And so you have to use 2 backslashes in the command when you want to just print 1. So if I put a backslash in front of this one, I put a backslash in front of this one, then you'll notice that the command will change color and you'll be good to go at that point. So you always have to put a backslash in front of other backslashes, quotes, I should say double quotes or single quotes. Then the only time you have to do that is if you are specifying something in quotes itself. So there's a quote here, there's a quote here. So if I want anything in this to be printed up like it's shown, I need to put a backslash in front of this backslash, and I need to put a backslash in front of this backslash. If I had a quote mark, you see how everything past it went black? I would need to put a backslash in front of the quote mark, and then it'd be good to go. It would print just this. When you print this up, what's going to happen is it's only going to print 1 backslash. It will ignore the first backslash. So it's just a designator, and this is in anything you ever make in C or with the Arduino. So just know that that is a thing that will occur. So this will print up our first command. Next thing we have to do is we have to press enter, right? And so we can't type like keyboard print and then put in quotes enter. Like that doesn't work. And this is where our next command here from our library comes into play. So we have this one called press and release. We'll put that in there, paste it. So press and release int code int count. So I'm going to get rid of this. And what I want is I want to put the enter key there. So I can go over to my Teensy Arduino normal keys here. And I can see, all right, well, which one's the enter key? Like which one do I need to use? Oh, key enter. All right. So right here I will put key underscore enter. And that goes blue, so it's good. And then I just want to hit it 1 time and put my semicolon at the end of it, and we're good. At this point, I want to delay, let's say 4 seconds for this command, right? And so that's how this works. At this point, now it's just rinse, wash, and repeat. So I'm going to I will probably just take and highlight all of this, Control C, hit enter, paste, and then just come back up here and there we go. And so you can keep pasting that on down the line and then change these, just the commands, to your different commands that you want, right? So so I've got a Wimmick command already prepared here. I'm going to paste that in there. All right, and so just so you kind of know what we're doing, we got Wimmick, QFE list, piping that to more like we normally do, carrot that thing over to the to where we want it to go, which is user profile, desktop, right? Same thing we have here, computer name. In fact, if I just wanted to build the next one, I'm just going to delete this out real quick. So, so that's our Wimmick command right there ready to go. If we wanted to do another one, right? So let's do Wimmick disk drive, list brief, pipe that to more. And then we're going to send that over. Remember to add the extra caret. If you used 1 caret up here, make sure you're adding 2 carets down here so it doesn't completely overwrite the file. It appends it. And then, like once again, just copy this, paste it down here. Make sure you have your double slashes in. Write it to it. And so this just keeps going, right? Like you just keep copying and pasting your commands as far as you want to go. Eventually you're going to get to PowerShell, right? So I'm going to show you an interesting way to do PowerShell. So what you can do is you can do like we did for the rubber ducky, and you can just pop PowerShell, right? So if I take this block. And take this, type in PowerShell, and then I can keep going. I can, type in put my PowerShell commands in, and write it, and then do a double exit just like I did before, right? So where it'd be keyboard print and be exit, and then keyboard print again for another exit. You can do that. That's fine. But one thing you can do from the command line that I haven't shown you until right now is let me pop another one. There we go. I can take and I can run the full PowerShell command from the command line. So I showed you before I could type PowerShell in and just jump over to PowerShell. We can also do this, PowerShell, and then what you want to do is put a quote mark, and then you can type your full PowerShell command. So I've got my list here. So I'm going to get this really big, nasty one here. All right, so as long as you put the whole thing in quotes, you should be good to go. So what that just did, let me erase my file here. So if I take this, just type PowerShell all in quotes, hit enter, you'll see it's going to pop a file up here, and there's my output. So I don't even have to really go over into PowerShell and then type each individual command. I can just type PowerShell and then quote everything in quotes, because if you don't put these quotes, what happens is the command window doesn't see these pipes correctly and it doesn't work well. But PowerShell, put everything in quotes and then end in a quote. So that way I never have to pop to PowerShell. So what I can do is take this guy, copy it, and paste it in here. And this is where it gets a little interesting, because now my escape command, you'll notice that all the wording went black, because in my escape command, remember you have to use an escape character anywhere there's a quote or there's a backslash, right? Quote is single or double. So I have to put a escape character in front of this quote. We'll scroll on down, and I'm going to open this up a bit. Minimize this so I can get to the... we're going to put another escape character in front of this slash. We're going to put an escape character in front of this slash. And then this last quote, the next to last quote I should say, escape character there. And so now what happens is it actually, when it types up the thing that you want it to type up, it's going to type up all of this. The two outside quotes are the quotes that are needed just for the command, for the C to be put in there. I guess you say that the required quotes to hold your command. But this quote and this quote are inside of the two outward ones here. So we have to put an escape character here, we have to put an escape character here, and we have to make sure we put our escape characters, our escape slashes there, so that we show C like, hey, you really need to, that's funny, you really need to recognize these as text and not as an escape character to do something else. So cool. So hopefully you understand that particular thing. So what we did is we just took and just combined this all into one thing. If you wanted it then to exit, right, just grab this. If you wanted it then to exit out of the command window, we only have to exit once. So we can take this, keyboard print, exit, enter, and delay, and we're good. So the way that we're going to load this thing up, and so I'm just going to use these commands for now. First thing you want to do is verify, where it says compile. Up here there's a check mark. So this is going to make sure you wrote your code right. So if you hit the check mark, it's going to compile stuff. And there's one thing I forgot to do. I forgot to mention to you. Mine compiled right, but yours might not compile right because of a particular thing. If you go to Tools, make sure you choose the board that you're going to run as, whether it's Teensy 4.0 or Teensy 2.0. So I'm going to choose the Teensy 4.0. So that was my problem. I compiled it before I'd chosen it. So go up here, check Teensy 4.0. The other thing you need to check is the USB type. We want it to be a keyboard. So you click on keyboard. Once you click on that, so now you got Teensy 4.0, you got keyboard. Should be able to click verify and it will compile the sketch and let you know if there's any problems whatsoever. Common problems that might occur: forget to put stuff in the bracket, you leave out a semicolon, so hit that, show you what it looks like. It'll go crazy, let me know, hey, there's something wrong with this line, but no, it says at the bottom, expected a semicolon before delay. Oh, okay, yeah, I forgot my semicolon, so I'll put that there. So that's how it compiles. Once you've got your it compiled up, you'll probably notice that there was a small window that popped when you did it. It's this little guy. If it's not on your screen, let's see if I can grab this. If it's not on your screen, it should be minimized somewhere or behind a window. But this is your Teensy loader. So once you, normally with an Arduino, you click the upload button and it uploads it to the actual device. Well, sometimes what happens is you've got these Teensy's set as something that is maybe a Dell keyboard or something like that, and the computer actually believes it's a keyboard. And so if that's the case, if the computer believes it's a keyboard, it's not going to know where to upload it to when you hit the upload button. So this little Teensy Arduino piece here, what it does is it makes it to where it will kind of, when you hit the button on your Teensy, it uploads the code to it. So if you see my fat head in the corner there, I'm going to show you how to upload this stuff. Grab yourself a micro SD cable or the other SD cable. I forget the name of it. Mini SD, I believe, or not micro SD cable. Sorry, micro USB cable. Plug it into your Teensy 4.0. You're going to plug it into your computer, and after you plug it into your computer, you're going to want to hit the button on the Teensy. So it'll take a second to recognize it as a Teensy. Just hit the button. You'll notice that it'll do that. Now here's the thing. I've just unplugged it after I did that. Once you hit the button on the Teensy, you'll see it load the code into it. Then it will start the countdown to run everything that you've told it to run, right? So I unplugged it just because I wanted everybody kind of be on the same page here. I don't know if you're going to be able to see the LED blink, but I'm going to plug this guy in, and it's way down here. It's going to be hard for me to do this. So we'll see if it worked. So plugged it in. It's thinking. It's going to wait 8 seconds up. The LED just blinked. Pop command. Looks like I screwed up my first command. I'll just have to figure out what I screwed up there. Oh, I forgot my... I forgot to put my environment variable up there, right? So got a few problems. This is what happens when I code on the fly, is I screw lots of things up. That's okay. So if I looked, I said, okay, well my system info command didn't work for some reason, and that's because I didn't set my environment variable right. See? So I had a $sign there instead of a %. So I want to put my % there. I want to put a % here. Verify it, and then take my Teensy, stick it back in, and this will pop up. Hit the button on it, reload it. Now I'm ready to go again, and it'll run system info correctly this time. And so you're just doing that. Like if you've got several layers of debugging here you got to go through. Your first is, does it compile, right? So you're banging your head against the wall, being like, ah, crap, why isn't it compiling? Then once it does compile, then you want to make sure it's giving you the output that it needs to give you. So in my case, I noticed, oh wait, system info isn't loading right. All right, well I need to rerun. Need to figure out what's wrong with system info. And so you'll have to do that. You have to make it like go through a process to kind of figure out what to do. Couple things I just want to show you real quick, because I know we're kind of getting to the edge of our time here. I should be done about 15 minutes. Is how to change the PID and the vid of this thing. So like right now, if you load this in, the PID and the vid comes back to say, hey, that's a Teensy device, which is fine. But I don't know, like with the computers you're defending, like if they have any kind of USB detection or anything on it. So one of the things that's helpful is like, you can convince this thing it's a Dell computer. Two places to do that. And this isn't going to be, let's see, there it is. Hopefully you can see, if you have a Teensy 2.0, this path right here that's at the top of this Notepad++ file, this path is where you're going to find a file called usbprivate.h. So it's in your Arduino folder, under the hardware folder, Teensy, AVR, cores, USB HID, USB private.h, or USB_private.h. So if you go to that file, you will find something that looks like this, and it says vendor ID and product ID. If you find this file right now, you will notice that those vendor ID and product IDs are not the ones that are there for you, because I changed them earlier. This was the original PID and vid that was there, and I just remarked it out and stuck this in there. And you're like, well, what is that vendor ID and that product ID? Well, I'm going to move this up here and bring up my website so that you can still see the path. There is in the Skinny R&D page, there's a PID vid information on devices link. If you go to that, it'll bring up this, and it will show you a gigantic list of every PID and vid you can imagine. So if I say, okay, well, what is the vendor ID 413C? So two things come up. So that's a product ID. There it is. 413C is Dell computer. And they say, well, what product ID is 2003? Well, 2003 is a keyboard. So now every time I plug in my Teensy 2.0 into a Windows box, it's going to go, or actually any box, it's going to go, oh, this is a Dell keyboard. I need to load the drivers for a Dell keyboard. If you want to make it more convincing for the people looking on, when it pops up down at the bottom of your screen and it says loading driver, it'll say, if you change where it says define stream product, then within the quotes, you write whatever you want to. You could write, happy, whatever, happy clown keyboard inc.com, doesn't matter. So, but I type Dell keyboard, and it will, at the bottom, it'll say loading drivers for a Dell keyboard, right? So that way you can kind of have the full role, I guess. But once you change those things, so you're going to put 0x and then the PID, or the vid, and then 0x and the PID, you're good to go. Save it. When you save it, it might ask you to have admin privileges to save it. Just say yes and save it. So that's how you do a Teensy 2.0. So hopefully everybody's got this down by now. This is Teensy 4.0. So you go to this hardware/Teensy AVR cores Teensy 4/USB_DESC, and it's a little bit more involved, because what you're going to do is come down. It'll pop up looking like this, but you're going to have to scroll down a good ways. And a Teensy 4.0 can be a lot of different things. And so in the Teensy 2.0, they had a different file for every different thing the Teensy 2.0 could be. In Teensy 4.0, all that's in a single file. So you'll see, okay, this is for a serial device. This is to mimic a keyboard. So what you do is you come down here where it says keyboard. You change this PID and this vid to the one that you want. And then instead of where it said, I changed it to Dell keyboard, you have to put, for the manufacturer name, you put it in this. So you would put, D, E, L, L, and then erase all the rest. And then down here where it says manufacturer name length, you need to then change that to 4, because it's not 11 characters, it's 4 characters. And then I'd probably use the product name same, just keyboard, product length 8. So anytime you change something here, you need to change the length below. That's all. So save that off, and now every time you load this up, it's going to think, oh, this is a Dell keyboard, right? So, you know, if you change the PID in the vid here. So you can make it anything you want, a joystick, a mouse, whatever. It's all up to you as to how you want to craft this thing to look to a computer when you plug it in. I have two different things here that I'll put up on the website after this is over. One is, where is it at? Here it is. So I have written, no, I put it over here. Sorry, got too much stuff on my window. So this is an Arduino load of all the commands that we covered in class so far, in the way that I just taught you how to program this. And I know some of you are pretty good at C, and you're watching this and going like, oh my gosh, he's got a loop there and he's not using the loop for a loop thing. Ah, it's killing me. And for you people, I have a different payload that, oh, nope, that's not the one I want. Let me see, where's it at? There. Nope. I'll get it right here in a second. Bring up the right Arduino thing. Sweet. Here it is. So this is kind of a different way of doing it. If you're really used to Arduino and you know about using the loop and you know about char stars and you have like such stuff like that. So this is all the commands. What I did is I just took all the commands, I stuck them in an array with a pointer. I then have it go through the setup process just like I did before. And then the loop, all the loop does is say delay, keyboard print, whatever is in the queue up here, press and release it, and then iterate on this. So that if you type this first, you're going to type this one second. It goes through each one of these commands, printing them one at a time, and then at the end, every time it goes through this loop, it checks to make sure it hasn't gone past the number of commands in the list. Once it does go past the number of commands in the list, you type exit 0. And that's important. I forgot to tell everybody about that. There is one thing you need to do at the end. So anyway, thing is if you want the nice, the kind of concise code, nerdy code, I guess, you can download this one. I'll have it on the website. I'll also have our normal payload sketch that we did here, and just kind of fully done. But the one thing you need to remember, the code that you just wrote, I would not write that code So the interesting thing here is that it goes exit and then it delays for 4 seconds. If you wait 4 seconds, it will start to run all of this code over again. So if you want to kill this, you type in exit 0. Oh, exit 0. So that is just the just exit parentheses 0 with a semicolon, and that will break the loop and just shut the whole thing down so that it doesn't continue to loop through everything. So yeah, key part there at the end of it. If you're going to explicitly say all the commands down a piece at a time, make sure you throw in an exit 0 there, and it will kill the loop for you. So I think that's just about all I've got as far as the content. If you are a government customer and you want to get signed up on the website, please, if you go to skinnyrd.com, there is, to go incognito to my own website so I can go to the register page. There's a register button. You can click that and it will give you a place to sign up to get emails from me, and gives you access to government products and training classes, stuff like that, and references that don't appear on the normal web page. So you can sign up for that. If you're just following me because you enjoy the content and you're not a government customer, thanks for coming. And even if you are, I'm on Twitter at SkinnyRad, I believe, Instagram, LinkedIn. You can find me just about anywhere. If you go to the social skinny, or go to Skinny R&D, there's to the webpage where the live stream is, and the side there is little buttons that will reach everything where I'm at, even GitHub. I have a GitHub account, it's got some stuff. So if there's anything that you need, just get in contact with me, and that's where you can find me. Yeah, I think that's it. If you have any questions, like I said, feel free to throw them in the comments. I am going to leave the chat, leave the stream going for just a little bit, so you guys, if you need to talk to each other, that's fine, or if you need to ask me a question, I can pop back on and answer those for you. But thanks for attending. If, like I said, let me know if you have some issues with any of this stuff loading or whatever. I'll try the best I can to answer it. And as far as content for next time, let's see, I think high likelihood we're going to be looking at how to build, get a PCB manufactured. So we'll use a software program called KeyCAD. And I can step you through that and show you how to create a schematic, and then from a schematic make it into a circuit board, and then from a circuit board where to go to order it for cheap and have it delivered to your house. We can take a look at that, or just do some basic electronic stuff. Or if you have ideas about what you want to see, just let me know. But yeah, so I'm good. So if you got a question or you want to chat, I'll be in the chat for a little while. I'm just going to kill my audio and let this play out for another 5-10 minutes, and let you guys go. So I will see you next time, and thanks for coming.